So when working through these warm-ups, we are simplifying radical expressions. Remember, we have two options when simplifying radicals. We can either make a prime factorization tree, or you can try and factor out perfect squares of this radical. So what I'm going to do for each of these is use the prime factorization tree. The reason I'm going to use these is because I know that I won't miss any of those perfect square factors. So I'm just going to start with factoring 252 by 2. So that leaves me with 126. Well, I can factor 126 by 2, which would give me 63. Factors of 63 will be 7 and 9, and factors of 9 will be 3 and 2. At this point, what I want to do is pick my pairs, things that have a match. So 2 has a match, so do my 3's, which means they're going on the outside of my radical. They can leave, remember they have a date. So 2 times 3 leaves the radical, while 7, who does not have a pair or partner, has to stay at home. Now the other number that we cannot forget about is the 3 that was already in my problem. It stays there. And remember, when I have these types of problems and I'm factoring, the whole point of factoring is that I am multiplying numbers to get to that. So any numbers where I have left over, whether it's on the inside or outside, I'm going to multiply to get to the answer. So 3 times 2 is 6. 6 times 3 is 18. So my final answer for 3 on the square root of 252 simplified is 18 on the square root of 7. I'm going to do the exact same process when it comes here to 2 on the square root of 405. I know that a 5 will go into 405, so it'll give me 81. Factors of 81 are 9 and 9. Factors of 9, 3 and 3, and factors of 9, 3 and 3. So looking for pairs, a pair of 3's and another pair of 3's. Because I have 2 pairs of 3's, they both must leave the radical and go on the outside. I have a 5 that's left over, so it stays inside the radical. Again, I have a number on the outside that I cannot forget about. We just bring it down, so we multiply everything by 2. And our final answer will be here, 2 times 3 is 6, 6 times 3 is 18, so 18 on the square root of 5. Things don't change that much when we're looking at variables. Now the only thing, we have groups here. I could list out 6 x's because that's what x to the 6th means, and then look for pairs of 6 or of x. So I would have x to the 3rd because that is a pair of x times a pair of x times a pair of x. Now this works all the time, but I'm not going to want to do this if I have an exponent of an extremely large number. So I can take this same exponent, x to the 6th, and divide the exponent by 2, because again, we're looking for pairs or groups of 2. And because I get a whole number here, I know that I'm going to have 3 x's on the outside of my radical. I can do the same thing with y to the 4th. So 4 divided by 2 is going to equal 2, which means I'm going to have 2 pairs of y outside the radical. In this case, everything leaves, everything has a pair, therefore nothing will be left on the inside. So number 4 is one of these problems where I do not want to list out 105 x's. Instead, what I'm going to do for x to the 105, I'm going to take 105 and divide it by 2. That'll leave me with 52.5. This 0.5 tells me that I have an x left over. So I have x to the 52nd power on the outside. There's 52 pairs of x's. But on the inside, this 0.5 tells me that I have one, like a pair of socks, when you can only find one of those. I only have one of those 2 pairs left over. So there should be one x left on the inside. I'm going to do the same thing with my y. I have y to the 201st. So 201 divided by 2 will leave me with 100.5. So it'll be y to the 100th power with a y left over. That'll be my final answer. When dealing with number 5 here, I've got numbers and variables, so I just want to be consistent. 243 I can factor out of 3, which leaves me with 81. Then factors of 81 are 9 and 9, factors of 9, 3 and 3, factors of 9, 3 and 3. Remember, I'm still looking for pairs here, so I have a pair of 3s and a pair of 3s with a 3 left over. So I'll have 3 times 3 on the outside with a 3 left on the inside. Now I need to come back and deal with my variables. So I have x to the 7th. So 7 divided by 2 is going to give me 3.5, which means there is x to the 3rd on the outside with an x left over on the inside. Then I still need to deal with my y's. So y to the 8th power, 8 divided by 2, because I'm looking for pairs, is 4. So that means I'm left with y to the 4th, and there was none left over. So when I get ready to write a final answer here, I just combine. 3 times 3 is 9. I have x to the 3rd, y to the 4th, and then on the inside is left 3x. Number 6, 216. You can pick any of the pairs that you like. I know that a 2 will go into 216, and I'll go 108 times. Then I'm going to break down 108. That'll be 2 and 54. I can break down 54 to be 9 and 6. Factors of 9 will be 3 and 3. Factors of 6 will be 2 and 3. So now I want to deal with my pairs here. I have a pair of 2s, a pair of 3s with a 2 and a 3 left over. So on the outside will be 2 times 3. On the inside, 2 times 3. I also still have to deal with my variables. So I have x to the 11th. So 11 divided by 2 is 5.5, meaning that there are 5 x's on the outside with an x left over on the inside. And then I do the same thing for the y's. There's only one y, so 1 divided by 2 is just 0.5, meaning there's no y's on the outside and 1 left on the inside. So as I get prepared to write my answer, 2 times 3 is 6, x to the 5th. And on the inside, we have 2 times 3 is 6x, y. So this is what we did in yesterday's lesson, simplifying the radicals. Again, we're using prime factors and looking for pairs here. Finally, on this warm-up, we have a little review of adding and subtracting polynomials. Remember, this can reoccur on our milestone, which is coming up. So we want to combine like terms. I have x squared. I'm going to combine that with anything else with an x squared. So we remember that there's really a 1 in front of the x squared. So we have 1x squared plus 5x squared, which gives me 6x squared. Then I have a 4x. I'm going to combine that with my negative 3x. So negative 4x plus negative 3x gives me positive 1x. But remember, I don't have to write the 1 in front of that. And then finally, we have negative 6 and a positive 10. So negative 6 plus 10 is going to give me positive 4. So when we're adding and subtracting polynomials, we're simply looking for like terms in order to combine. Now for number 8 here, notice we have a subtraction sign in the middle. So I'm going to distribute that subtraction sign. I'm going to keep my first polynomial the exact same way that I see it. I'm going to change the subtraction sign in the center to an addition sign. And then I distribute the negative, meaning I'm changing the signs of everything in the second polynomial. So if it was positive, it's changing to a negative. And if it was negative, it's changing to a positive. And at this point, now I just combine like terms. So 2x squared plus negative 4x squared gives me negative 2x squared. Then we have positive 3x plus positive 5x gives me positive 8x. And then finally,